Hello, this is my video for Unit 7 of Geometry. In this video, I will go over dilation and rotation in the coordinate plane. Okay, let's get started. In dilation, we have a point which is the center of dilation. Center of dilation is essentially the point that we are going to be dilating from. And we have the point that's going to be dilated. So here, the 0, 0 is 2 to the right and 3 up away from A. In order to dilate this by k equals 2, we would need to, again, go 2 to the right, which would be around here, and then we need to go 3 up, which is 2, 3, 1, 2, 3, 4, 5, 6, yep. So now we have a new point. This wouldn't be called A, it would be called A prime to show the difference between the pre-image and now the image. Now, what if the center of dilation does not equal 0, 0? In this example, we will be using triangle ABC. Triangle ABC is comprised of 3 points, A, which is 4, negative 3, B, which is 5, negative 1, and C, which is 5, negative 4. We'll be dilating this by 2. The center of dilation in this example will not be 0, 0, as we said before. Instead, it'd be 4, negative 6. So what changes if we do this from 4, negative 6 rather than 0, 0? Nothing really changes. What we would be doing is rather than going down 3 and right 4 to dilate it, and then we do that again, we would just be going up 3 for this one. So let's do that. For A, how many points away is this from the center of dilation? This is 3 points. So then we would just do that again, which would then be this point. This would be the new A prime. A is 1 to the right and 2 up. So let's do that. It's a little messy, sorry. So it's 1 to the right, 2 up. Let's do that again. 1 and then 2 up, which would be 4, 2. This would be C prime. Let's connect A and C, A prime and C prime. This is the start of our new triangle. Just like C, B is also 1 to the right from the center of dilation, but rather than going 2 up, we will be going 5 up. So let's repeat that again. 1 to the right and then 5 up, which, give me a second. This is negative 1, so it would be 1, 2, 3, 4. B prime would be here. So our new triangle, sorry about the mess, this is really messy. This was our old triangle. And now this is our new triangle, which would be, rather than ABC, triangle ABC, it will be triangle A prime, triangle B prime, and triangle C prime. So that's what we do if the center of dilation it does not equal 0, 0. This video isn't really about these types of dilations. That was more last unit. But if we wanted to do a decimal dilation, something like this, it would probably look like about this. I'm not going to go to another full example. And same with the negative dilations. Here you go. It would look something like that. It's essentially the same thing as just a regular dilation. As I said before, it's just a different point that we're doing it from. Let's begin rotation when the center of dilation is at 0, 0. I have 3 basic examples for this type of rotation. The first example I have is a 90 degree rotation. This rotation will be rotating 5, 5 by 90 degrees. When we rotate a point by 90 degrees, it turns from xy to negative yx. So for 5, 5, that would be negative 5, 5. And it would go from here to this. This is a 90-degree rotation. For a 180-degree rotation, rather than going from xy to negative yx, 5, 5 is going to go from xy to negative x, negative y. This will transform it from 5, 5 to negative 5, negative 5. Negative 5 is over around here on the coordinate plane, and it would be going from here to here. Let's write that down. For the last example, 270, just like these, xy is going to turn into something different, xy turns into y, negative x. That means it's going to turn into 5, negative 5. So then it would be around here. Let's draw the arrow. For 360 degrees, it would xy would just end up back at xy. If you can see what I mean. Let me do a little diagram for that. Let's say we had a point over here that we rotated 360 degrees. It would just go like that, like a circle. These three were very basic examples, but what happens if the point of rotation or the center of rotation isn't at 0, 0? There are two ways that we can rotate a point if it's not at 0, 0, if the center of rotation is not at 0, 0. The first one that we can do is making the center of rotation 0, 0. So if we have 3, 2 here, we would need to move it down 2 and 3 to the left. We'd also need to do that with the point that we're actually going to be rotating. So I'm going to do that in 3, 2, 1. There we go. Now we're rotating 2, 3 around 0, 0. So let's do that in 3, 2, 1. I didn't mention this before. This will be a 90-degree rotation. Because this is a negative, and because this is a 90-degree rotation, we are going to be taking 2, 3, and we're going to make it negative yx like we did before for the last example. That would be negative 3, 2. So I'm going to do that on the graph in 3, 2, 1. There we go. We turned A, which was 5, 5, and then 2, 3, into negative 3 and 2. So what we're going to do from here is reverse what we did. So we're going to put it 3 to the right and then 2 up rather than 3 to the left and 2 down. So I'm going to do that in 3, 2, 1. In the end, 5, 5 rotated around 3, 3, 3, 2 at a 90-degree rotation would be this point here, which is 0, 4. So that would be A prime, and this would be A. Now, the second way we can do it is we can create a new coordinate plane at the point we're rotating it from. So I'm going to do that in 3, 2, 1. So there, we've made a new coordinate plane, and we will be rotating 3, 8 around 3, 4, 180 degrees. So now we can just do that like it's a normal coordinate plane. So 3, 8 rotated by 180 degrees would be, let me pull this up really quickly. 3, 8 rotated by 180 degrees, we'd have to transform that into negative x, negative y. Or we'd have to take that and apply that to this. So it would, instead of 3, 8, it would be negative 3, negative 8. Sorry for all the pauses and the stuttering. My voice is still a little bit, like, not good. Thank you for bearing with me. So it would be negative 3, negative 8. So let's do that on the new coordinate plane we have. So negative 3, negative 8, negative 1, negative 2, negative 3. I don't think it's big enough. Let me make it bigger. Up in the last recording, it wouldn't be negative 3, negative 8, because we'd have to use the new coordinate point it would fall on. So this would be 0, 8. Or no, that would be 0, 4, sorry. It would be 0, 4, not 3, 8. So 0, 4, 180 degrees would not be negative 3, negative 8. It would be 0, negative 4. So 0, negative 4 on our new coordinate plane would be here, 1, 2, 3, 1, 2, 3, 4. This would be our new point. And this point is, what's it called? This is 0, negative 4 on this coordinate plane. So let's see what that point would be if we remove this coordinate plane. I can't really remove it because it's, well, pen. So this point would be, so this is 0, 1, 2, 3. So this would be x equals 3, y equals 0. So it would be 3, 0. So those are the two ways you can do rotation on a coordinate plane if the point is not at 0, 0. Last topic I'm going to be going over is transformation composition. This was a little bit simpler for me compared to the last couple topics. At least for me, it was. All it really is multiple transformations. Here's an example of something that is a transformation composition. So A is being reflected over the y-axis, and then it's being translated. It's going to be y minus 4x plus 2. So we go from a to a prime to a prime prime. And this is the notation for it. I hope you enjoyed the video. I'm still a little bit sick from the past week. I tried my best, really. Thank you for watching, Mr. Saenz. Have a good one.